This would be a great place to start discussions with Trace3 if you haven't already. So thank you to Trace3 and the team for being here this evening. Next slide. Our next sponsor is Snowflake. Snowflake will be a presenting sponsor, so you're going to hear more from Snowflake as we go into the evening. Snowflake is a data platform built the ground up exclusively for the cloud and delivered as a service. And Snowflake allows you to build a modern end-to-end data architecture with their cloud data platform. And as you can see in the slide there, Snowflake is available across all three of the major cloud providers, AWS, Google GCP, and Microsoft Azure. Snowflake can support a wide range of workloads, from data warehousing to data lakes to data science, and it's allowing you to use your data and consume all of that data to drive better business outcomes. You can kind of have this single platform that enables secure and governed access to data through the organization. And it's the only solution that helps eliminate complexity, cost, and constraints of typical other legacy type approaches. So thank you to the Snowflake team. Next slide. Our next presenting sponsor, and again, you'll hear more from Teradata. Teradata, they transform how business work and people live through managing the power of data. Teradata has the only hybrid cloud software of its kind, providing powerful access to leverage all of the data all of the time, so you can analyze anything, anywhere, deliver analytics no matter what. Available as a service, their cloud-based analytics gives powerful, flexible, what they call pervasive data intelligence across the organization. Next slide. And the way they look at pervasive data intelligence is that it brings valuable answers across all enterprise users. And so the ability to understand that the analytics and data that a business executive needs to make accurate transformational decisions might be different than the data that the CIO and the IT department need, might be different from the business analyst that's getting into more deep and timely type of insights. And so Teradata has the ability to provide that pervasive data intelligence. So thank you to the Teradata team for joining us this evening. I appreciate it.
Thank you, Steve.
Next slide. I think I'm turning it back to you, Naresh.
Yeah, thank you. So I wanted, before we go to Frank for a minute, so thank you, Steve, for sharing insights about the sponsors. One thing I'd like to ask for all our members here, as you go through the happy hour and through the entire session today, if you feel you'd like to have a connection with one of the sponsors, in the chat area, just put down connect me or connect me with XYZ, and then we will share that contact information with them directly. We just want to comply with our rules with SIM San Diego chapter and how we work with our members. So if you just put it that way, we'll flag that your name and we'll share that with them so they can connect with you folks. So thank you again. Now I'd like to turn it over to Frank Corigliano. We reached out to Frank to help us with the wine shipments. Hopefully all of you got some bottles of wine at home. And so Frank, welcome, and let's hear a little bit about Corigliano.
Well, thank you for having me. I hope everyone got those bottles on time. It was busy.
Clink, 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 clink.
Yeah, and so, just real quick, what you have in the box there is the Cabernet Sauvignon, which is our flagship red. It was the original grape that we planted when we moved to San Diego back in '91. So the family's been out here for 30 years. Prior to that, we were down in New Orleans. That's where I grew up. My father took a pizza business that he started in Syracuse and brought it down to the Bayou back in the late 70s and had about 35 pizzerias down south that he sold to a company you guys have probably heard of called Sbarro's back in '91. And that's when we really started the wine business, was when we moved out here to San Diego. We bought 20 acres of avocados and immediately started cutting down the trees and planting grapevines. And having been in the Italian restaurant business my whole life, it's been a joy. Wine and food obviously go together. I wish we could have some of our food available for everyone to pair with the wine, but basically, we selected the Cab Sauvignon because again, it was the original grape. It's my dad's favorite varietal. And an interesting tidbit, a little factoid for the next time you're enjoying a glass of Cab. You'll notice the other wine is the Sauvignon Blanc, and they share that name. The Sauvignon is the name that both wines share, even though one's red and one's white. The Sauvignon Blanc is actually a parent grape of the Cabernet Sauvignon. It was spliced together with a Cabernet Franc grape to create Cab Sauvignon. So the red wine we're drinking tonight is actually a descendant in terms of the grapevine of the white wine. So neat little fact. But if you're here in San Diego and you're on your way to Temecula, and that's what you usually do, I'm excited, to tell everybody about what's happening in the Highland Valley area. That's where our winery is. It's one exit south of the North County Mall. So if you're ever thinking of getting out and enjoying some wine, you can see the pictures there on the slide. It's all outdoors, and obviously with everything that's going on in the world, we've had to make some adjustments, but it's a pretty great experience if you get a chance to come out. You want to get away, for an afternoon, beautiful sunsets, as you can see there. But the whole family actually lives on the property, and we're all involved. I'm the oldest of three, and I've got a little brother and sister and kids of my own that are working at the winery. So it's just an exciting environment. I mean, we're Italian, so we love to eat and drink anyway. But I think the one thing I would pass on to everyone is, with everything that's going on, one of the things I'll never forget, Dad, taught us from an early age is to just find something, anything out there when you get up every morning and just celebrate. And, the glass is half full. You have to have that sort of mentality, I guess, in order to get by, with a smile on your face. So the wine definitely helps. So cheers again, salute. It was an honor to be invited to talk to you guys today. And I'm starting to see some of the other slides and thinking I could use some analytics for my business, some consulting. So maybe I'll be texting some of you guys, things like integration. And, we're still kind of a mom and pop shop. And so part of my job is to bring us into, the next technical age, I guess. And so I'm hoping to get some ideas from you guys. So
thank you, Frank. Cheers.
Thanks for having me.
And by the way,
cheers. Thanks.
The best pizza in San Diego County, in my mind. The brick oven pizza is outstanding, and the tiramisu as well. So that's my recommendation.
Thank you.
As a Sim board member. And by the way, Steve, I just felt the wine will let the numbers look a lot better than if you didn't have the wine. So that's why I recommend that. All right. So we're gonna now switch over a little bit. So we hope all our members, except for somebody who just signed up today, got your wine shipments. We're going to be randomly splitting up the members across the 3 Zoom breakout rooms. We'll be rotating our sponsors across after 20 minutes. The whole idea is for you to just have a happy hour. It's not a sales job. It's just more a chat and enjoy the event. At the end, we're going to bring everybody back to the main hall and transition to the main event. So have fun and see you back in an hour. Sam, I'll turn it over to you.
The irony was not lost on me, Troy. The small world we live in here in San Diego.
Someone the other day accused me of having this as a wallpaper, so I had to pull a book out.
Oh, that's awesome.
It was really a book. This is my Donald Knuth Art of Programming book. Yeah.
It's filled with Tom Brady book.
Oh my.
Oh, yeah.
He's deep. Josh is deep.
Pearl Jam book.
Jets fan.
Oh, I like that.
Welcome back. Thanks again to all our sponsors, Trace 3, Snowflake, and Teradata. And we're going to now move into the next session, which is a future of analytics in the cloud. And Kent Graziano, the CTO, Chief Technical Evangelist and Strategic Advisor for Snowflake. So, Kent, I'll let you share from this point onwards. I'll step out, and thank you, everybody, again.
All right, thanks. Thanks, Naresh. me get mine shared. And
if everybody else could go on mute, we'd appreciate that. Thank you.
all right, are you seeing my main opening slide there?
Yeah.
Last-
One
Right.
second, just before you go. So again, we really, if you folks have any questions for the sponsors, please feel free to use the chat session. We're going to have a Q&A to the tail end of the discussion. Additionally, if you want to have a follow-up, a connection, please on the chat, just let us know that so we can then introduce you post the event to the sponsors itself. So we'd like to thank you, Kent, to turn it back to you.
All right. Well, welcome everybody. Thanks for having me. We're going to talk about the future of analytics in the cloud, or as I like to think of it, just the future of analytics. For those of you who don't know me, my name's Kent Graziano. I am the Chief Technical Evangelist for Snowflake. I've been with the company for about 4.5 years. I joined back in the late days of 2015. There was only about 100 people in the company at the time. And it's had massive growth since then. It's been just a really exciting ride. This has been one of the best jobs I've ever had. I've been in the data space for well over 30 years. I actually started working with Oracle Technologies in the late 80s. And I got introduced to data warehousing by working directly with Bill Inman, the inventor of the data warehousing concepts in the mid 90s. And I was pretty much hooked at this time on the idea of business intelligence and analytics and data warehousing. And I could see this was where the industry was going to go. Just a big deal with what we're going to be able to do with data. And turns out, I think I made a pretty good call. The future's here. We're already in place. Gartner is predicting 75% of all databases will be in the cloud by 2022, which is not very far away. We're already halfway through 2020. I came across this great infographic that Domo puts out every year, and this was their 7th edition, about how much data we're generating per minute, and just way more than even I realized. One of the examples in here, 18.1 million texts per minute are being generated. On Instagram, we have over 55,000 photos being posted per minute. Uber, now this was earlier in the year, 9,772 rides per minute. Now I kind of suspect that was before the pandemic. That is certainly dropped off. I know my Uber rides have definitely dropped down to, well, basically zero at this point. So I haven't traveled since mid-March. And so that amount of data has definitely dropped off a bit. And then on YouTube, this one's probably gone up. 4.5 million users watching YouTube videos per minute. Like I said, pretty sure that one has gone up along with the Netflix one on here. Yeah, massive numbers. 694,444 hours of video being streamed. And you look at Netflix, Disney Plus, Hulu, HBO, all of these other streaming services. I suspect this has probably gone up in order of magnitude since the pandemic. I know it certainly has in my household. But what this means is we're all really pretty much drowning in data at this point. I never would have dreamed there was going to be this much, right? Now, IDC did this study a little while back, and their prediction is 175 zettabytes of data by 2025. Who would have thought of that? But it's coming from all sorts of sources now, instead of just our traditional on-prem ERP back office sorts of systems. We've now got third-party apps. We've got mobile. Everybody's carrying around mobile devices that are tracking you. I get emails from Google telling me how far I traveled every month. Of course, that number has also dropped a lot recently, but it's fascinating to see what kind of data is being tracked. And now you throw in IoT. especially in the healthcare space. We're seeing a lot more there. Is generating all kinds of data. It's not the traditional sources that we used to have. And while we've sort of mastered being able to store that much data, the challenge now is, how do we take advantage of the data so to provide insights to our business? And we've really got to figure out how to make it, easier to build the data platforms and manage these data platforms. Forrester did a study a while back and found out that most companies want to be data-driven, but very few really are any good at putting that data into action. They found 73% of the firms that they were talking with aspired to be data-driven. So, aspire, they're hoping to someday be data-driven. Well, I would like to think it's a little more than hope that's going to get us there, and how we're going to effectively start to drive better decisions from our data. Then this number of 29% of the firms that were any good at turning it into action, well, I think groups like this, we're all about increasing that number, adding to that number, having our organizations be some of those organizations that are good at turning the data into action. Now, I've been, like I said, at this for a long time, and I always figure you got to look at the history. If we're going to plan to be more successful in the future, it's really important that we understand the past and how we got to where we are today. So I'm going to do just a quick little review of, the data world and what we've done. And this is really reflective of my experience working in data warehousing, designing, and being an architect over the years. We started off pretty much with the direct data mart, or is what's commonly referred to as the Kimball approach. You get source system, you build a specific data mart and write some routines to move the data from the source to the target. Then you want to add another source to it, and we have some new processes feeding into that data mart. Then we get a new requirement, perhaps for a different kind of information that we want to collect. And so a new source and new data mart. And these are all just very specific business use cases where we're moving the data into a specific structure to solve a specific problem, to answer specific questions. And while these are great for prototyping, long term, there turned out to be, there's some downsides to all of this. A lot of redundant coding, is you're pulling the same data multiple times and sending it off to different locations. Becomes harder and harder to make sure everybody's really getting the same view of the data. And of course, the business rules change, and as we all know, they always change the business rules on you. You've got to change the code, and now you have to change the code in multiple places. So you have multiple potential points of failure as you're trying to move this data around and get a good view of your data. Now, the second most popular approach is a central enterprise data warehouse approach, often commonly thought of as the Inman approach, named for the father of data warehousing, Bill Inman. You have a core enterprise data warehouse that really becomes your integration layer. So you load the data once from the source into this integration layer, and you build your data marts then off of that. And what we're really trying to do in these scenarios is, bring the data in once, right? Store it once, do your transformations once, and hopefully get a better chance at having a single source of truth for all of your downstream marts. Now, this gives you those advantages from a long-term maintenance perspective, fewer routines that might change, is a little easier to integrate multiple sources, but it does, tend to require more disk because you're storing the data in one central location. And then in many traditional architectures, those data marts are also replicating the data. So that's, no panaceas here, nothing that's really solves all of these problems. The corporate information factory was kind of the next thing that came up. It's a conceptual architecture that came about with from Claudia Imhoff and Bill Inman about how we put a little more formality around this whole concept of an analytics infrastructure with things like data warehouses and operational data stores exploration warehouses, metadata management, and really getting a lot more formal about how we went about this. And today, this is more of what I see in the sort of a typical BI landscape, data warehousing landscape, analytics landscape that we see these days, where you have lots of different sources now, as I mentioned earlier, not just OLTP databases, but now we have weblog data and IoT data. You've got some ETL processes, you've got some streaming processes. In some cases, you have Spark, you have data lakes, data warehouses, data marts, ODSs, all sorts of things, all trying to feed this data to the data consumers. And you really end up with a lot of moving parts. But over the years, the technology really has changed, and it's changed how we work with the data. The concept of data as an asset's not new, but now we're starting to talk about that a little bit more and take that a little more seriously, especially in recent months. We see that changing quite a bit. With the changes in technology, it's changed not only how we work with the data, but it's also made it easier in many ways to turn that data into actionable assets for our business. First, the rise of the cloud. Unlike traditional platforms that were built with the scarcity of resources in mind, the cloud has offered us unlimited capacity, both for how we store the data and how we process the data. It gives us an opportunity to run an unprecedented number of workloads at a high performance in a centralized platform. Secondly, the explosion of data, as I already mentioned, it's continuing to grow both size and variety. And with all this new data, there's just tons of insight potential in that data if we can figure out how to tap into it and how we can harness that data. And then lastly, there's a diversification of analytics and really a democratization of the data. Arguably, everybody today is an analyst, or maybe you might call them a citizen data scientist even. When, where, and how we do the analytics has been completely transformed with a lot of the new tools that are available. And it's really getting pushed into every corner of our organizations. And we can expect, I think, the demand for analytics to be served up in this manner and be more accessible is really going to continue to grow. Now, while all these things are true, our struggle for the data and the problems that we've bumped up against for the last couple of decades, I've been working in this space since the mid-90s, still seem to exist. How can we incorporate new data faster and do data sources? We don't want to wait too long for that data. How do we experiment with the data? How do we make a data science sandbox available, right? And serve the data science community and not have our reports be too slow, right? And spend all this time and money and administration trying to tune. And how do you tune for these very different kinds of workloads? Now, throughout my career, I've seen this sort of evolution from on-premise data warehouses to our first generation cloud, Hadoop, and then all the way into the cloud. The very first data warehouse I ever did was in the mid-90s at the National Renewable Energy Lab in Golden, Colorado. And I think our data warehouse was maybe 10 gigabytes. And that was something new, and it was huge compared to the other systems that they had before. We were doing a monthly extract of data from a COBOL system and loading that data in. And I remember it was, a lot of separate tables. I was doing it all in SQL manually. I had a table with all the transaction details in it, but then I had a weekly summary table and a monthly summary table and a quarterly summary table and an annual summary table. And we hand wrote a graphics package around it so that the business analysts could see it and they could drill from the high level down to the low level. And under the covers, of course, we were manually just pointing at these other tables. And that was a big deal. But over time, it's grown. I mean, now we've gone into, hundreds of gigabytes then into terabytes, right? And that became a big deal. And pretty soon, the standard systems couldn't handle it. The standard databases couldn't handle it. And so we had new data warehouse platforms come around to handle this very large sets of data. But then we moved to the cloud. And the first generation of cloud data warehouses really were virtual images often of the on-prem. And so the features and characteristics were more or less the same. A lot of times it was infrastructure as a service, still a lot of configuration from the DBAs of the world, having to work with that. And it could handle, you know, the still sort of SQL things, but still couldn't handle massive concurrency and really didn't scale the way many things in the cloud did. We had Hadoop and the data lakes came along and really did help us solve this problem of how do we store effectively that much data at a reasonable cost, because now we're getting into hundreds of terabytes and petabytes of data. And that was really a turning point for us to be able to do this, to store structured and semi-structured data at commodity costs, and trying to address this broader democratization analytics process. But it was still kind of difficult to use. Many people had to use MapReduce, where so many of us who came out of the earlier analytics world, we knew SQL, right? And that was important. So the next step in the evolution was cloud and development of systems that were built in the cloud for the cloud, being able to take advantage of that less elasticity and the on-demand nature of the cloud so that we had the opportunities to try to do some very new things. Now, of course, the ecosystem is continuing to grow. There are more and more tools available, almost seems like on a daily basis. So we have your data integration tools and your data streaming tools and your BI and reporting and analytics tools. Those were the kind of the core of the data warehousing and analytics world for so many years. And now we throw in data science, these various kinds of data science tools and Spark-based tools, and just all kinds of connectors that we have to deal with. And like I said, the data's evolved. We're no longer do we just have simple data from a single source. We must now accommodate not only structured relational data, but semi-structured data as well, including things like JSON, Avro, Parquet that are coming from mobile and online services, apps, and log systems. Now, we really can't talk about data without talking about data lakes, right? So how do these fit in? First, the thing I always want to be clear, and I tell everybody I talk to, data lake is a concept, right? It's not a technology, period. Okay, so for most companies, a data lake's a design pattern. It's a computing approach for solving a business need to provide a data repository to collect a variety of data. It's structured, semi-structured, unstructured, all of these types of data in a single place, and then to enable analytics from on top of that. You know, the assumption is a data lake approach is needed because the traditional database system couldn't handle the level of scale and variety, and it was very true. In the early days, it was very, very expensive. If you're going to try to store hundreds of terabytes or even petabytes of data in a traditional database platform, it was very, very expensive. So this was definitely a problem that we needed to solve. Unfortunately, you know, as the Gartner quote here shows, data lake implementations haven't all been that successful, right? The real failure rate, according to Gartner, is more along the lines of 85% rather than 60%, which is what some folks have thought. And so while it's a great idea, it's been hard to implement. You know, well, why, right? There's a variety of reasons why we've seen these fail. Most commonly, the reasons are slow performance, high complexity, and poor governance. So being able to have discrete access control, you know, there's been some very famous hacks, you know, where people have had their systems penetrated, where things weren't properly encrypted, where some of the data has gotten out, and that's certainly a problem. And these are all things that people really are concerned about as we get more and more data. You know, we don't want to see our queries getting slower. We need to be able to access the data in a timely manner so that it is able to drive valuable insights for our corporations. And another Gartner quote here, they're predicting by 2021, which is again is like next year, 70% of mature organizations will have more data flowing from data lakes to data warehouses than vice versa. And when I first looked at this, I had to think about this for a few minutes, and I realized several of the customers that I've worked with were indeed flowing data from their data warehouses into their data lakes. Right? The data lake, they had built data warehouses, so they had legacy data warehouses, and when they were wanting to merge that data with semi-structured data and unstructured data, they were having to take it out of their relational system and put it into a data lake in order to make it available to a broader audience. And so, like Gartner said, they're seeing that's going to turn around. It's going to go the other way. That while data lakes aren't dead, as a concept, they're definitely not dead. People are doing it in blob storage now. The data is going to start flowing the other way. It's going to become the basis for the data warehouses, I think, as a persistent staging area. So now, what about data science, machine learning, AI? We, of course, have to talk about that as well as part of the broader analytics spectrum. Well, more data is definitely better. The statistical significance is important when we're doing machine learning and AI. The more data points you have, the better off you're going to be. You can train your model better if you have more data. So the diagram on the left there, we have a small amount of data. We may be able to do it fast, but you get less representative results of the real world. The more data you have available to train your models, the better your results are going to be, and therefore the higher probability of the project success. So as you're testing your algorithms and your theories, it's way better to have 10 data points than 2 data points, and way better to have 1 million data points than 10 data points. And the more that you can get, the better off you're going to be in what the results are that are coming out of what you're trying to do. So what's the ask from the business then is just more data. We need to streamline and accelerate your data science process by making more data available preferably in a single repository, so that it's much easier to integrate the data science tools and the ML libraries with the data and make better business decisions by having that data all available and be able to build data products, but also support analytics. So from a perspective of, what's the future look like, and where are we going? And I'll say from my perspective, where do we need to go? And it's really looking at something that is really a hybrid data repository, a single hybrid repository that supports the best of all of these approaches: data lake, data warehousing, analytics, data science, to be able to capture batch or streaming data, or really batch and streaming data directly, and store unlimited amounts of this kind of data, structured and semi-structured, using cloud storage. And that's part of the promise of the cloud, is to be able to allow us to do that in order to get better results at any scale, right? And this is where we need to go to get the most value from our data. Minimize the moving parts, eliminate the need to copy the data, store it once, use it many times, so that it's easier to govern and track the lineage of the data, and have it available in the cloud, in the public cloud. Hopefully, we want to be able to support all kinds of clouds, but in order to give people access to that data with a simple service, try to eliminate as much maintenance as possible so that it's easy to load the data and query the data, and really democratize that data. So how does Snowflake help in this regard? During COVID, we've seen challenges in managing supply chain. Building a flexible and efficient supply chain is a continuing challenge in many industries because networks are getting more and more complex, and it's hard to share data across multiple parties. The Snowflake Cloud Data Platform has finally made the promise of a connected supply chain a reality. It has the ability to share data in real time across hundreds of partners. Companies can now have visibility to their end-to-end supply chain in a single platform. And specifically, I'm going to talk a little bit about McKesson. So they learned very quickly, as one of the largest pharmaceutical distributors and health information providers in the world, they're using Snowflake's Cloud Data Platform to access third-party data sources as they build out a more sustainable supply chain and reduce operational inefficiencies. And of course, in this time of pandemic, this is critically important to all the organizations that McKesson serves. So they're using IoT data from distributors in combination with 5G data. They can now optimize their pharmaceutical supply chain by more accurately measuring and responding to shifts in the product demand. I've even seen that here in Texas. We have a grocery store chain called H-E-B, and they actually had a pandemic plan because most of their food for the grocery stores, a lot of it's sourced locally here somewhere in Texas. And they had a plan in place for what were they going to do when something like this happened. And they had a lot of information already set up. And because of that, we had, good supply of groceries. We've never lacked for produce. Only very briefly did we have any issues with accessing meat. And so having supply chains and having the data exchange between these organizations has been very critical, as I said, especially during this time of pandemic. Now, a little more of the story around McKesson. For those of you who don't know, McKesson's number 7 on the Fortune list with $214 billion in annual revenue. They're involved in all sorts of healthcare, not just pharmaceutical supply chain, but they employ 78,000 employees across 16 countries. They're responsible for 1/3 of all the prescription medication deliveries in North America and serve 2.1 million customers every day in Europe as well. They have a massive data distribution system. It's the biggest one in the world. I actually worked for McKesson Specialty Health here in Houston prior to coming to Snowflake on a big data warehouse system there. And I learned working there that they had the largest implementation of SAP supply chain in the world. So you just can imagine the amount of data. Well, their situation was, they spent 4 years trying to lift and shift their on-prem solutions to the cloud and really only got a small fraction of it done. Data analytics was part of it and showed up in all parts of their initiative. They had multiple decentralized analytics teams who were embedded in the business, but still kind of operated independently in silos. And they had to manage this exploding amount of data that they were dealing with to try to serve the business needs. So they really focused on going to the cloud in order to try to increase their speed of delivery and to lower their costs. So the solution for them is they decided to go with Snowflake as the cornerstone for their cloud migration and allow them to centralize their technology and their data management solutions into a core team or technology hub and continue to keep the analytics closer to the business, letting the business users really have access to the data and improve their supply chain at the same time, as I showed in the previous slides there. So by removing the on-prem constraints that were frustrating them, they enabled 60 analytics teams, and these are teams, not users, but 60 analytics teams, so they could spend more time on actual analytics than on the data and managing the technology plumbing that held it all together. So on a single platform, they were able to migrate to Snowflake in less than 3 months, completed their migration, and observed an 86% improvement in the load speeds and a 5x factor on their complex query times, going that much faster. And all along the way, managed to improve the governance as well because they eliminated all of these data silos and gave them much more visibility to the data. Another one of our well-known customers is Capital One. Their cloud data platform has enabled them to get the data they need to serve their customers better. And that's their primary goal. Their old on-prem system was starting to hold them back. I actually, in working with them, learned that they had a single person whose entire job was to kill queries because their system was so overloaded that trying to add new workloads was nearly impossible. And so somebody's entire job was to wait for that call where there was a higher priority query that needed to be run, say for a report for the CEO or the CFO, and they would have to go find queries to kill in order to free up the compute. So it's very difficult for them to get their data, especially when they're trying to do personalized experiences for their customers. Complex queries, just, forget about it. It just they weren't really able to do it. With Snowflake, they had the higher concurrency they needed for a large number of data users and for a larger number of applications. At one point, they actually loaded 1 trillion rows of JSON data every day. They were trying to get 15 years of weblog data available to enhance their Customer 360 program. And so they were able to effectively merge their data lake, data science, and data warehouse use cases all within the Snowflake platform and do things that they previously had not been able to do. And I've had people ask me, it's like, why would you load 15 years weblog data? And it's like, well, they had that data, and that was a lot of their interaction with their customers was through their web site. And so with this information on how the users were interacting, they were able to get a better picture of the needs and requirements of their customers and tie it with their traditional data from their CRM system and their account management systems in order to get much better insight on what their customers were needing and what the customers were doing. So now they're able to handle the complex queries and, like I said, actually joining data between JSON, semi-structured data, and relational data. And that's one of the features of Snowflake is we have a data type called variant, which allows you to ingest semi-structured data into a column in a database table natively. So no pre-parsing, you don't have to split it up, and our engine knows how to read that data so that you can write SQL against it. So we have some extensions to SQL for accessing the different elements of a JSON string, and it's just as performant as if you had pre-parsed it and ETL'd it into separate tables and columns yourself. So you're able to load the data very quickly, which is how they were able to load 1 trillion rows in a day. And they did that until all that data was loaded, and now they load about 1 trillion rows of JSON data a month to keep up to date with what their customers are doing.
Hey, Kent. Hey,
Yes.
Olga. Hey, so this is pretty topical. I know we still have a little bit to go. We have about 6 minutes and we're getting some questions.
Okay.
So the first one is around data lakes and data warehouses. If you can have a clear definition of the difference, and then specifically the roles and responsibilities and use case. And then going into that, how Snowflake differentiates from a big NoSQL traditional solution like Hadoop.
Okay, actually I was going to get to that in just a couple more slides. So let me get through this next piece, and then I will get to a little more discussion on those particular topics.
Okay, we only have about 5 minutes left.
Oh, really? Okay.
Okay, thanks, Ken.
All right, talk fast. So at top of everyone's minds right now is, of course, the COVID global pandemic. And several months ago, and we mentioned this in one of our breakout rooms, one of our partners, Starschema, actually made a COVID data set available using data from Johns Hopkins and the CDC and a bunch of other agencies, where they've curated that data into consumable data sets. So they've done the data cleansing, they've put it into a standardized schema, and it's now available through the Snowflake Data Marketplace. So you can instantly access that data. And we've had several thousand customers actually take advantage of that. And it's helped them solve a lot more business problems really quickly instead of having to find, load, and cleanse all of that data themselves. And just as a final example, closer to home for all of you in California, just 2 weeks ago, the state of California decided to make their COVID-19 data available for free through the Snowflake Data Marketplace. And this data set includes case data from California Department of Public Health, as well as hospitals and lab data, case demographics, and more. And this is the type of transparency and instant access to data that the cloud is driving to really help the next wave of public-private collaboration and providing a new, really much needed level of transparency in near real time. Now, all of this stuff is been made possible because of the platform that Snowflake has evolved. It's the only platform that was built specifically for the cloud. And as you can see on here, to Olga's questions, your data lake and data warehouse, as I said, these are concepts. And the way people deal with the data is really somewhere the differentiation is. Data lake is you're loading raw data. It's semi-structured and structured data both in this case. And as I described with our variant data type, you can ingest the semi-structured data directly into tables and still access it in a schema on read capacity using our SQL. And data warehousing, the way I differentiate that is it's more of a curated, it's modeled, hopefully in my mind from a semantic business perspective to allow more people to understand the data. And it's where you may integrate multiple data sources, where the data lake is going to be all the raw data from however many sources you have. The data warehouse is where we're going to try to integrate that together to get some consistency and normalcy, and then provide the real, I'll say, auditable, trackable single source of truth for your downstream applications, which, either of these can serve data science needs as well as data application needs. And then we have our data exchange, which is what Star Schema and State of California are taking advantage of. And it's really because of our architecture is the thing that makes Snowflake unique and enables these sorts of features. So we invented this thing called the multi-cluster shared data architecture. And with this, you have a single set of storage. Under the covers in Snowflake, you're defining them as schemas and databases and tables. And under the covers, we're using blob storage on either AWS, Azure, or Google to store the data. And so it's instantly elastic. You don't have to predefine anything. As you load data, we expand the space, and as you delete data, we contract it. You only get paid. You only pay for what you're using. And with that, this is what allows us to support both data lake and data warehouse in one place. And then the separation of compute from storage allows us to configure multiple independent compute clusters for different workloads. So you can have a single node cluster, which is really 8 threads to support, say, streaming data. Just needs a little bit of compute. Maybe a 2-node cluster or 4-node cluster to support some ad hoc queries or some dashboards. And then a totally independent 8 or 16-node cluster for data lake and data science, machine learning applications, maybe connecting with our native Spark connector. And that really allows the platform to support all of these different kinds of workloads. And because we've separated that compute from the storage, it also allows us to do this data sharing and the data exchange, because you basically are creating a curated data set and giving it a name, it's a schema, and then you're going to share it with other Snowflake accounts, and to them, it becomes a read-only database. They don't have to import the data, they don't have to ingest the data, they can simply query the data from their Snowflake account. And so the data marketplace works that way with Star Schema, and what the state of California has done, you sign into the data marketplace, you sign up to consume that data, and you instantly have that available as a database now in your Snowflake account that you can now write queries against, and you can cross-join that data with any of your own data in a data warehouse or a data lake that you may have. And so you can easily augment your analytics. And this is what people are doing with this data that's being shared from these other organizations. And so this is the thing that really kind of makes us unique, allows us to have this secure collaboration. It's completely governed. You have full visibility as to, obviously, you determine who you're sharing the data to. You determine the masking policies on what they can see and what they can't see, the role level access control, all of that is part of the platform. Does that cover those questions there, Olga?
I think so.
Okay. Right, I'm not seeing any others. Well, there's a lot going on in the chat. So yeah, I'll just finish off with, Snowflake, we've been around since 2012. Our founders have over 120 patents now between them, and actually another 27 for what we're doing. We've been around in GA since 2015, and that's when I joined the company right after they went GA, and it's been just a very exciting time. I'm just going to leave you with a couple of really cool metrics that I like. If I can get my my clicker to work on this side, there we go. We're now processing over 469 million queries a day across our service. The largest single table has 41 trillion rows. When I joined the company, it was 23 trillion rows. And it's over a half a petabyte, just a single fact table with about eight attributes in it. And they're doing aggregates on this every week. The largest single database in Snowflake has 14 million tables. And that to me is the instantiation of a data lake. They're loading all of their raw source data into Snowflake, persisting it there, and then building downstream data marts and analytics warehouses from that. The single customer with the most data has 29.2 petabytes of data, and that's compressed in Snowflake, and we get anywhere from 3 to 5x compression. So that's somewhere around 90 petabytes of data. And the largest customer has over 11,000 users, and their most recent high water mark was 9,000 users active at the same time. And so our mission really is to enable organizations to be data leaders in their industry by being able to take advantage of their data, driving better business decisions and better outcomes for their customers, their partners, and all their clientele. So in closing, what my ask is, what are your plans for the rest of 2020? Are you going to be a data leader? Are you going to be a follower? And the choice really is yours. You need to look ahead and think ahead, and don't just focus on solving today's problems. While those are important, we need to plan as thought leaders and IT leaders, what are tomorrow's problems? And how are we going to solve tomorrow's problems when we have 175 zettabytes to wrangle? We really need to be the leaders and be the change and figure out how we're all going to get there. Thank you very much.
And thank you very much. That was really insightful. In fact, after all that information about data, I think we all need a drink as well. So a lot of fun facts out there. Okay, so I'm going to we're going to switch over now to Teradata, machine learning and deep learning with analytic processing engines. Stephen, I'll turn it over to you to share and take it from here. We have about 45 minutes, and then we'll wrap up after that. Thank you. Stephen, are you going to take it over?
Do you see the screen now?
Not yet.
Not yet.
You need to share it.
I did share. Mm-hmm.
No, Steve. Okay. There we go. It's coming up. Yep.
Yep, got it. Got it now.
Great.
Wonderful.
There we go.
So I'm the Chief Technology Officer for Teradata. That means I have responsibility for the technology strategy as well as how the strategy gets deployed in the field. I came to Teradata. I did a startup company coming out of MIT with a bunch of buddies that we did our PhDs together and massively parallel processing. And we had a startup company, and then Teradata eventually acquired it. That's how I came into the CTO role and been working with the company for quite some time. So what I'm going to talk about is not so much the data itself, but what do you do with the data once you have it? And if we look at analytics, we can talk about, in very high level, 3 phases of analytics. So most people start with descriptive analytics, which is really about what happened in the business, understanding, how did I perform against my key performance indicators, and getting balanced scorecards, and looking at the data and understanding sort of the past. And I reckon that to the rear view mirror in your car. And I think many businesses spend way too much time looking at the rear view mirror when really you need to be looking forward. If you spend all your time looking at the rear view mirror, you're going to crash. So the whole point of more advanced analytics is to use the data, what's happening now, what's happened in the past, and to predict what's going to happen in the future before it actually happens. And then prescribe what is the intervention that I want to take in order to create the outcomes that are interesting for me. So I saw in the questions there were some people that were asking about use of analytics in nonprofits and so on. One example for Teradata relevant to this whole pandemic thing is CMS, the Center for Medicare and Medicaid Services, which is a government organization, so it's nonprofit. They pay essentially for the health care for disabled and elder people and so on. They're the largest healthcare insurer in the US. When the pandemic started to unfold, and because their population is very much at risk, they took the 14 years of historical data they have around their beneficiaries and were able to do analysis to understand, as the pandemic unfolded, where were their high-risk populations, where were the breakouts likely to happen, and then work with providers, healthcare providers, to make sure that the right PPE, the personal protective equipment was in the right place, the right pharmaceuticals in the right place, and so on. And there was a very interesting collaboration between different Teradata customers, the healthcare providers like Healthcare Corporation of America, the insurers. Most of the Blue Cross Blue Shield plans in the United States are Teradata users, the United Health Group, Center for Medicare and Medicaid Services. In an almost unprecedented way, they came together and did a whole bunch of analysis to figure out how to optimize the supply chains and getting the right stuff in the right place. And so this is a combination of predictive analytics to figure out where those places would be, and then prescriptive analytics to figure out what action you're going to take as a result of that. So these three phases of analytics, I'm going to focus mainly on predictive and prescriptive analytics. And we're going to talk about how the shifting of the decision making goes from humans pointing and clicking on graphical user interfaces to get answers, to use of machine learning and deep learning in order to get faster, cheaper, more accurate answers to questions. For me, there was a huge sort of light that goes on when the computer can actually do better than the humans in very complex tasks. And I'm a hardcore chess player, and I remember in the World Chess Championship a few years ago. This is a picture of Magnus Carlsen. He's on your left on the screen. He's been the reigning world champion in chess for the last 11 years. He's from Norway, and in the last game of the World Chess Championship, against Fabio, who's the Italian-American who's on the right side, he actually offered Fabio a draw to that game. And then he went on to win because he's a very good speed chess player, and that's how they break the ties. But as they are going over the gameplay, the computer that they were using to analyze the play at move 68 predicted a forced checkmate in 60 moves. So it did a 60 move look ahead, which if you play chess, that's a very, very good look ahead. And Magnus Carlsen, who had given up the game into a draw, you can see the shock on his face when the computer predicted. When I say predicted, it is a deterministic outcome. It wasn't a probabilistic prediction. It is, these are the moves that you take to get forced checkmate in 60. And so chess is a completely deterministic game. and computers have been challenging chess players for a long time. But this is an interesting case where you got this very far look ahead going on. But we can do this in many different fields. If you are being diagnosed for cancer, you don't actually want a doctor to do the diagnosis because they get it right about 95% of the time. Now, again, it depends on a lot of things. How good is the data and the type of cancer and a whole bunch of factors. But a human will get it right about 95% of the time. A deep learning program with a multi-layer neural network will get it right about 97% of the time. So you do a significantly better. So the difference between 95% and 97% may not seem a lot to you, but that is a big difference in terms of improvement in the quality of the diagnosis. More interestingly is if a doctor works together with a piece of deep learning software, they'll get it right 99.5% of the time, right? So it's not really, people think about AI as, automated intelligence or artificial intelligence. I like to think of it as, in best practices, augmented intelligence for many of the use cases. So there are some cases where pure automation works best. There are many cases where augmentation of human decision makers is actually going to perform even better. So I'm using chess as an example, but in healthcare diagnosis and in making predictions of, what product is going to sell how many units in each store based on the promotion that you're doing, we can do much better with machine learning than you can ever possibly do with human decision makers. So there's this interesting study that was done by some academics, a combination of Yale University and Oxford University. When will AI be better than humans? Now, when I talk about AI, I'm really going to narrow AI down into essentially deep learning, using machine learning and deep learning to predict the future based on historical data. And already today, we can do much better than humans in financial forecasting, marketing campaign targeting, asset management, condition-based maintenance, HR recruitment. This one's a little bit debatable because there's known biases that get introduced essentially by the humans that build the predictive models. But for a lot of things, the software is already doing much better than humans. Things like corporate strategy and merger and acquisition decisions, well, that's probably better off with augmented intelligence than purely automated intelligence. But anybody who's not using some form of machine learning for any complex decision is not making the best decisions that they could be making. And when we look at the ability of this machine learning to impact our business, the technology, the mathematics have been around for more than 50 years, right? So Marvin Minsky and other people at MIT and at Stanford and other places at Yale, they developed the mathematics for this, decades ago. But only in the last few years has the computation been such that we could actually run models at scale and predict the future before it actually happened with any reasonable cost. And as we continue to drive down the cost of building the machine learning models, they absolutely become ubiquitous. They will be in everything. So many of you already have cars that know how to park themselves. Your machine learning is being used to figure out what ads that you see or what recommendations you get. Netflix uses very aggressively machine learning to understand how to make recommendations for the content that you view on their site, just as a few examples. So there's all this great stuff doing with machine learning, but as Ken pointed out, there are a lot of shiny objects out there and there are a lot of promises, and when you have technology-led people chasing shiny objects, business value is not always delivered, right? A recent example of that is this whole Hadoop phenomenon. Someone was asking in the chat room about, Hadoop and Hadoop distributed file system and so on, and the data lakes that Kent was talking about. The Gartner study showed that 90% of data lakes were useless. Not just poor return on investment, but useless. You spent a lot of money and you got nothing. And a lot of the points that Kent made around, poor governance and, data dumping, they weren't data lakes, they were data dumping grounds, data swamps. And they weren't delivering value, overpromise and under delivery. And this machine learning has a whole lot of promise, but in order to get the delivery and get the value, we need to deliver quickly, and we need to do so in a way that is consistent and sustainable. So there's all kinds of problems where people are building these data pipelines. They're inconsistent. You get non-repeatable data science. So I come from a science and engineering background. If you don't have repeatability, it's not science, right? That's politics. That's economics. Science means you can design an experiment, you can have repeatability, you get full lineage, and you can build it and deploy it sustainably. So we need to make sure that when we're deploying these machine learning models, that they are completely sustainable and we're deploying for high value. It's not a point about how much data you have, it's a point about what you're doing with the data and the value that you create. So this is the reason why at Teradata, we created this software called Vantage. So many of you will know Teradata if you've been in the industry for a while as a Caltech spinoff that created a relational database, arguably the first fully scalable relational database capable of exploiting thousands of processors in a massively parallel processing architecture. And so in that engine, essentially it was a SQL engine. But as the machine learning and predictive analytics and prescriptive analytics emerged into the marketplace, you come to realize that although SQL is a very powerful language and does lots of great stuff, it doesn't do everything that you need in order to create value. So I'm from Silicon Valley originally, and in Silicon Valley, some years ago, we got into this whole SQL versus NoSQL war. And the NoSQL bigots to say, you SQL people, SQL is an interesting language, been around for a long time, but you guys are dinosaurs. Go sit over there in the corner with the COBOL programmers. Your life is over. And we're going to go do MapReduce and Hadoop and big data and so on, and we are the future. On the other side, in Silicon Valley, there's no shortage of SQL bigots. The SQL bigots say, you Hadoop people, you're a bunch of idiots. You're doing flat file programming. This MapReduce thing is so inefficient. You got no proper optimizer. You've got no indexing, no schema. It's you guys are a bunch of idiots, right? And you get these religious wars going on. And I would argue that at the extremes, they're both stupid, right? Religious wars, the extremes are not smart people, right? And so a good engineer, we don't take religious stands. We essentially say, look, take good ideas from wherever they come from. And so at Teradata, we embarked upon a project which internally we called NewSQL. It's not SQL, it's not NoSQL. It's how do you take the best ideas from both of these? And this is where the advanced SQL engine came into being as an evolution of the Teradata relational database. The advanced SQL engine, we of course took all the advanced relational technology that we've been developing for many years in terms of the cost-based optimizer and the fine-grained parallelism and all that good stuff, and then extended it with NoSQL capability. The ability to do things like time series as a data type and all the appropriate operations on time series, the ability to do in database with R and Python, the ability to do late binding with JSON or even XML. So the idea is that in this advanced SQL engine, it's not about just SQL, it's about the things that you need to do to go beyond SQL. And then to be able to extend that with other software engines, like the machine learning engine and the graph engine, so you could do advanced analytics, and this software can run either on-prem on a bare metal appliance, it can run on commodity hardware on-prem or in any data center you want using VMware, or it can run on any of the major North American clouds, AWS, Azure, or Google Cloud Platform. So you take the software and you run it wherever you want. And what we did was we separated the compute and the storage. So in the black in the middle is the Vantage software, which are the engines, and you use whatever tool you want to use on top of them. You want to use Jupyter, you want to use Tableau, you want to use SAS, you want to use R, use whatever tool you want to use on top of that. Using open interfaces, you have access to this hugely powerful parallel engine with these advanced analytic capabilities. But we separated the compute and the storage. So the whole idea is one copy of the data, and you can do all your advanced analytics on that one copy of the data. But that one copy of the data doesn't have to be in a single file system. You can have highly structured record-oriented data for which it makes sense to have a relational store, either in a record-oriented format or a column-oriented format, depending on what makes sense. If you want late binding, you might use Avro or JSON. If you're getting a feed from a partner in a very simple data format, you might have something like CSV format. For the data that you want to store in a very low cost, but also a higher latency for access storage media, you might use the native object stores of AWS S3 or Azure Blob Storage or Google Cloud Services, or even an on-prem object store. Now, we also recognize that a lot of people have made investments in Hadoop. You may not be done sweating those assets yet, so you could also have in other file systems like Hadoop distributed file system, you might have in Cassandra, you might have in MongoDB. So you should be able to access the data wherever it makes sense. And there are, of course, different trade-offs in performance and economics for accessing that data. The point here is this software, you run it wherever you want, and the file system is hierarchical. So I can have data persisted in solid state disk drive and hard disk drive on native object store. And based on the temperature of the data, we can migrate the data up and down the storage hierarchy to optimize, again, performance and economics within the environment. And when you're working with very large data volumes, we have Teradata customers with hundreds of petabytes of data in production. This isn't some benchmark lab or something like that. Hundreds of petabytes in production. You need to be able to scale, but you need to do it economically so that you're storing the data at the right price per terabyte, but still having access to that data. And remember, price per terabyte is not really the measure that matters. It's what is the cost of value? What is the cost per query? And what is the value that you get from each one of those queries that you're running in your environment? So when we think of analytics, as kind of 3 steps at the highest level. The first step is preparing the data, often referred to as the feature engineering. And this is the hard work to prepare the data and make it ready for training the model and ultimately deploying the model. You're going to end up building a feature store. There's a lot of experimentation, so you should be able to provision a data lab and be able to experiment with the data and understand which data has the appropriate data quality, which data has the predictive power that we need to understand which customers are likely to affect and so on. So there's a bunch of cleansing, a bunch of what we generally refer to as data wrangling necessary to do that. And as Kent described, you need to be able to do this at scale, right? When you're working with the ability to predict rare events, in order to have statistical significance, you need to work with very large data sets, especially when you're working with the more advanced models that use nonlinear prediction. So 50 to 80% of the time in the whole sort of advanced analytics space is typically spent in preparing the data, and scaling that is very important. Once I've done that feature engineering and feature selection, and it's more than just doing simple aggregates and filtering, right? I need to do things like binning and normalization and testing for predictive power. This requires beyond straight SQL type of capability. Once I got the feature store, then I'm going to do my algorithm selection. I'm going to do my test and training set splits. I have to do the model optimization. I might engage in hyperparameter tuning. There's a whole bunch of stuff in training the model. And you know, you're likely to use libraries that may be provided by a commercial player, but they may also be provided by an open source player. So, you know, historically, commercial players in this space might be someone like the SAS Institute, but increasingly with the more very advanced analytics, you might be using TensorFlow, you might be using PyTorch, and the ability to take the data in Vantage and write it out to open data formats like Parquet or JSON and other formats where these open source tools can have direct access to that data. A single copy of the data for your feature stores allows you to train the model. And then once you have trained the model and you have a model description, then that model description can be deployed and executed fully in parallel on the Vantage software. And the Vantage software can directly access the data in those open data formats on the native object store or on other file systems that you might have in your environment. And the important point is that you're doing that at scale, because ubiquitous machine learning is a scale problem, right? So when you talk about vertical scaling, we talk about being able to score 100 million households of who's likely to defect in the next 30 days and why they're likely to defect and what intervention that I should take. So people like Verizon and AT&T use the Vantage technology to do exactly that kind of things on huge numbers of households. We were talking earlier about supply chain and optimization, and Kent used example of HEB as a grocery store chain that does supply chain. Pretty much all the grocery store chains are doing this kind of thing, but it's not about one model scoring. It's about thousands of stores or hundreds of stores, 100,000 SKUs into thousands of different categories, and running training millions of models. So people like Walmart that use Teradata software, they're not running one model for a category across all their stores. Each of their stores are hyper-personalized in their assortment. And they change all the time based on preferences and based on the demand chain analytics they do. So most of the retailers, not just in the US, but in the world, are using the Teradata technology to do this kind of scaling, both the vertical scaling and the horizontal scaling. People like Walmart and Target stores and Safeway and Whole Foods and so on and so on. Some are deployed in the cloud, some are deployed on-prem. It depends on what their strategy is and where their strategy leads them in terms of their deployment economics and their readiness to move the workload in terms of data gravity on the cloud or on-prem. So the whole point of Teradata Vantage is use your favorite tools if you're a data scientist. So you might be using RStudio. Jupyter is probably the most common of the tools that are used in data science workbenches within the Vantage environment, but you want to use commercial tools like SAS or Dataiku. Use the language that you want, SQL, R, Python, Scala, your choice, right? And data can be in a large range of formats as Kent described. So late binding with things like JSON and Avro, or highly structured data and different object-based file systems for accessing the data. And then being able to use the appropriate analytic functions from the open source community as well as from the commercial community in order to get the job done in the best way possible. So as I mentioned before, you choose where the Vantage software is going to run. Bare metal, VMware, on top of any of the clouds exploiting the native cloud capabilities in each of those, including the native object stores. You decide where to run, and it might be a hybrid environments for some of our customers, and some are 100% in the cloud, and some are still doing more of the advanced data science work in the cloud, but they might have on-prem for the production workload, depending on their industry and regulatory concerns, sovereignty concerns, et cetera, et cetera. So our goal is to simplify how to deploy these advanced analytics, to have an integrated experience where you can do the feature engineering, the training, as well as the deployment without duplicating data, without moving data, and to make it scale both vertically and horizontally, and be able to do this in an enterprise way with high availability and with proper financial governance and proper workload management. So we talk about the advanced SQL engine. Don't think of just the ANSI SQL capability. Think of all kinds of in-database capability. When I say in-database, it means that we're able to scale it out both vertically and horizontally with advanced mathematical functions, geospatial functions, et cetera, and being able to do this together with the machine learning functions to do things like path analysis, sessionization of clickstream data or customer care interactions, doing the attribution, doing the scoring, doing the model training on a single copy of the data. So this makes a huge difference. So for example, we have a very large e-commerce customer, the largest in their marketplace, and they were using R on a local workstation, and they were sort of on that local workstation, they had only so much memory and they had only so many CPUs. When we brought that in Vantage to execute across their parallel system, they're able to take those 4 hours down into 10 minutes. And this makes a huge difference in terms of the number of times that you can turn around the model and the level of granularity that you can go to scoring the model in order to get this more precise and more accurate predictions and prescription of the actions that you should take. In another case, a large logistics company had huge amounts of data. This is a multinational company, and they're able to figure out based on the performance of their deliveries, based on cost, based on competition, and so on, something that was taking them, over 12 hours, we got that down to 4 minutes because they were having to take the data out of the previous database that they had before we replaced that database. They were taking it out because that database didn't have beyond SQL capability. They were taking the data out. They were manipulating the data on a NoSQL platform. They were then putting the answers back in. We could do that all in place without copying, without moving the data, and we're doing it in single-digit minutes instead of double-digit hours. So again, a huge difference in performance, which then translate to much better outcomes. So the advanced SQL engine sort of extends the ANSI SQL standards, but not everything belongs in a SQL engine. So the ability to have other engines containerized, Dockerized, and ability to share the same copy of the data. So for example, if I'm Verizon, I can use structured data to build models to predict churn, but I can also look at calling patterns between subscribers, and I can predict what is the collateral damage. If subscriber A defects to another provider, who are the other subscribers that are connected to the defected subscriber, and who is at risk by how much, and what intervention should I do to save them? So graph engines can be used to understand relationships between people in a calling circle, or can be used for doing things like anti-money laundering to understand the flow of money from sources and sinks, to understand where shady things are happening and we need to step in and prevent money laundering. So in addition to working with relational models, you also want to be able to work with other models of computation. Again, same copy of the data, but a different engine that has a different set of mathematics. Relational mathematics are different than graph mathematics, but in the end, it's the same data. It's the same call detail records that you're analyzing with relational structure than if you're analyzing with a graph engine. And yet you need it to be able to scale, and you need to be able to take the calculations that you do with the graph mathematics and then feed that into your feature engineering to use that as additional attributes to understand what's going on with your client base. So there are a whole bunch of machine learning functions and graph engine functions. We're not going to go through the details here. You can get a copy of these slides later, and someone from Teradata would be happy to walk you through all the details of what's going on here. So at a high level, what are some of the most common use cases? This is certainly not exhaustive, but some of the most common use cases. You want to be able to sort of predict what's going to happen in the future. And you can use models which are linear mathematical models, logistic regressions, linear regressions, and so on. You also have the ability to do non-linear models like random forest and shallow neural networks and so on. Segmentation, where we can sort of understand based not just on demographics, but on behaviors. So understanding customer journey and segmenting based on the customer journey. And customer journey might be the path to buy, but also might be the healthcare journey. So we're able to, for example, predict someone who is going to have back surgery, but create an intervention that takes them on a different path that allows them to actually avoid the back surgery, have a much better quality of life and a much lower cost of care by intervening with, for example, appropriate physical training, et cetera, et cetera. Understanding causality, what is causing the impact of high sales in a particular product? And if I promote this product, what are the other things that are going to be impacted by that? And doing context aware analytics using unstructured and semi-structured data, things like sentiment analysis with features that help you understand how to classify behaviors and understand how to create features that can then go into understanding how to predict customer behaviors. We talked about networking and the graph analytics earlier, and hypothesis testing as part of the data science that you're doing. Science is really about having hypothesis, testing the hypothesis, understanding what is the relevant cause and effect for the phenomena that you're interested in understanding. What I wanted to do was end with a couple of examples of some organizations that have used these capabilities across different industries for advanced analytics. So this first one is a major manufacturing company, and they wanted to understand how to do the maintenance on their equipment to sort of optimize uptime, but also maintenance costs. So they're taking, instead of just looking at, how many hours of operation that they've had, and using the manual to figure out, okay, after every 10,000 hours we need to do maintenance, that turns out to be very ineffective. You spend 40% more cost using this milestone-based maintenance than using condition-based maintenance, taking sensor data, using that sensor data to understand the behavior of the machine, and then predicting when that machine is going to fail before it fails, and then prescribing what is the maintenance you should do, whether that's adjustment of a part, whether it's replacement of a part, and being able to do this on a continuous near real-time basis without taking the machine down. So using streaming data feeds, they were able to significantly reduce their maintenance costs, while at the same time as they also reduce the number of unplanned outages on their machines. So huge value to their business by using advanced analytics rather than just using the milestone-based maintenance that they were doing before. So in this example with the IoT analytics, we could determine what were the event paths that led to shutdown of the machines. We could capture those event paths early on and then intervene in order to get much better outcomes. This next example is a major retailer. I'm pretty sure that every one of you, at least in pre-COVID times, would have been in this retailer on a regular basis. Their goal was to understand the customer experience across multiple channels, right? So when I say in, you might have been in their retail store online, or you might have been in a brick and mortar store, and to be able to understand interactions across the multiple channels. So taking the clickstream data and taking the in-store data and integrating that data to really understand the full path to buy, to do attribution for their promotions, their in-store promotions, as well as their online promotions, as well as search engine optimization. Were they spending the dollars in the right way? They were able to significantly increase the efficiency with which they were able to acquire and retain customers in terms of the targeting that they were doing using these advanced analytics. This next, and in this case, we're using the graph engine to understand influencers within the retail buying community, together with the advanced SQL engine to do statistical analysis, and the machine learning engine to taking sentiment analysis from social media sources to really understand the full breadth of customer experience analytics within the retailer. This is an example of a global bank what they wanted to do was predict which customers were going to defect. And looking at all of the events, the online events, the in-branch events, the call center events, and they were able to take the data and analyze using Markov models to predict very accurately which customers were at risk. And again, how am I going to retain those customers? So the training set data, they look for which customers did a transfer, and then they could look back 1 event, 2 events, 3 events, 20 events, 40 events, and figure out what did the path look like to when a customer transferred the money out of their bank into a competitive bank. And then once they could understand what were the markers, what was the right time to intervene, they were able to significantly reduce the number of account closures by intervening at the right time and, getting a customer service event or other kinds of interventions in order to save those customers. The last example is using semi-structured data, which are basically movie reviews. So think of this as not necessarily a movie theater, but a online streaming service, and taking movie reviews from across multiple sources, capturing those in JSON, and then mining the text to understand what were the sentiments around the movies that were being viewed, and then extracting key facts and dimensions that could be used for their marketing execution. I'm not going to go through this code. I just wanted you to see that it was real and it was implemented with the functions that are built into the advanced SQL engine and the machine learning engine, and doing the advanced mathematics, all built in, all parallel, all fully scalable, to then be able to understand sentiment and identify, how to extract the key sentiments from the descriptions of the content by the movie reviewers, and then we're able to understand which are the best candidates for the recommendation engines for these movies. And also we're able to extract terms like, for example, when people would often say edge of the seat, we could take these terms that people are using to express positive sentiment, and then take that positive sentiment and then play it back into the recommendations with no human, right? So we're able to automate that process of the recommendation engine, not only what content to recommend, but in what context we should recommend it to attract the viewers to view that content, right? So this edge of your seat is an example of an expression that we would extract and then sort of play back as part of the recommendations. So our target communities with the Vantage software, of course, the data scientists, these are the data R&D people who are wrangling the data and building the models and so on. But ultimately, the business users, they want to deploy those models, and they're going to work together with the IT folks, the data engineers, part of the enterprise data warehousing team, to deploy those. So you've got the consumption data engineers who are developing the applications, deploying the applications. You got the data engineers who are acquiring the data into the data lakes and then transforming and integrating that data into the enterprise data warehouse, and then making this capability available to the business users, enabled by the advanced analytics that the data scientist is initiating on top of the platform. Again, one copy of the data used for each of those, wrangling, training, and deployment steps within the advanced analytics. So the idea is to have agility from hypothesis to operationalization. So instead of taking, weeks to do this, you want to talk about doing, days to get things done. And that includes multiple iterations of, fail fast, test, fail fast again, and then get success. So at Verizon, the data science processes that they had were significantly reduced in the time from hypothesis to value creation and ultimately deployment and production at very, very high scale by orders of magnitude in terms of the elapsed time to bring value to their business. So key takeaways, the Teradata Vantage software allows you to combine both open source as well as commercial analytic tools to give a much better data science user experience, because it's an integrated experience where they can use their favorite tools, but they can use them at scale. And so evolving from a database platform to an analytics platform provider, where that software platform is deployable in cloud or on premises or in a hybrid environment. So with that, I'm going to stop and take any questions that might have come up.
Stephen, there's a question here on how do companies go about making the decision of which process to start with and what's the criteria?
So my view on which process to start with is, where is the business need? What I recommend that you do not do is start with the technology. Figure out what is the business need, what is the problem that you're trying to solve, and make sure that you've got a strong business sponsor that says, yes, I'm going to commit to creating value for that, and you've got the data available in order to enable that decision making. And by the way, I would not necessarily start with, we talk a lot about AI and deep learning and multi-layer neural networks. The reality is that, you probably don't want to start with those very advanced nonlinear models. Start with linear models, understand your data, understand the prediction, and then incrementally, iteratively improve the models using ensemble techniques in order to eventually evolve to a shallow and deep learning technique where you use the sort of an appropriate mix of the algorithms had different costs and different accuracies for your predictive models.
But that was a good point, Stephen, that second bullet of yours, which was make sure if you're tackling a problem, it's a problem you can understand that you can get the data for. Don't try to tackle something too difficult.
Yeah, so readiness is an important part. So readiness is part, is the data there? But readiness is also, are you organizationally ready to do it, right? So you can say, oh, we're going to do this cross-selling thing, and we're going to make tons of money by selling credit cards to people that have mortgages. But if there's no chief marketing officer that that has an umbrella across those different lines of business, and politically each product has their own marketing people and their own budget and their own P&L, you're not going to be successful. So you have to be ready from a data readiness point of view. You have to be ready from a cultural readiness point of view. You have to be ready from an organizational readiness point of view. And in the end, the technology, if you choose the right technology, that's the easy part.
So
and finding the right business, finding a champion in the business such that your first couple projects, you have a good champion is important.
Absolutely. Part of the organizational readiness. Yep.
So,
Yeah.
Stephen, I have a question to follow up other one earlier, since a lot of the SIM members seem to be very quiet, maybe drinking too much wine, I'm not sure, but it's for companies that are starting off the ground, are still not there in from a technology standpoint. Data management, everybody's always concerned about, I got all this data, do I need to clean it all up before I go there? What's the strategy to help them make that decision as they move forward? So just want to get your thoughts on that.
What's the decision that you're focused on?
On data cleanliness, because most people look at data and say, "Oh my God,
yeah, okay." So
why do I spend my money doing?"
I think one of there are a couple of key mistakes. One is the goal is not perfect data, because if you wait for perfect data, you will do nothing, and perfect data will cost you more than it's worth, right? So what you want is data that's fit for purpose, and so you let the use of the data determine how much you're willing to invest. So you need to think of data quality management as an ROI investment that you're going to make, right? And so in the data lake, and Ken kind of hinted at this, the data lake, that's the raw data as is from the source systems, not modeled, not cleansed, and so on. When you bring it into the more curated, I'll call it data warehouse, then you're going to sort of bring it together and make it fit for purpose. But my goal would be to do the data cleanup as far upstream as possible. So when you do the data defect root cause analysis, in almost all cases, it's not going to be a technology defect. It's going to be a business process defect. So you fix the business process upstream, in order to get high quality data into your data lake and then ultimately into your analytic ecosystem. But you let the business improvement opportunity, requirements for data quality drive the investment that you make. And it's not a data quality cleanup project. Those always fail. So it should be a continuous improvement process for getting the data into the state that you need it.
Great, thank you.
But data quality metrics will be part of the process, because as you move forward, you can use those metrics to continually improve that data quality.
Absolutely.
And
Absolutely.
Mike Zill actually has a question as well. Mike, do you want to ask it, or do you want me to read it for you?
No, I don't mind asking. Some of us work in relatively small companies. Maybe we have 20,000, 30,000, 50,000 records of a process, and maybe that's a couple 100,000 steps. And we're trying to predict, very much like you did on the banking, where the customer is going to leave. In my case, I want to know if the patient is going to actually go through and fulfill the prescription or not, let's say.
Yeah.
And it's a complicated, it's not the kind you go down to CVS about. So we could talk about the details later, but how many rows, how many data points are sort of required to be able to build a predictive model, or is that just, it depends?
It's definitely, it depends. Part of what it depends on is the algorithm that you're using. So for example, linear mathematical models, you can be successful with a much smaller sample set. With the nonlinear models, like with these multi-layer neural networks, don't even think about that unless you've got millions of samples.
That's, yeah.
Right. So this is why it's, people get all excited about the new technology. Oh, I'm going to go do a multi-layer neural network and, give me access to TensorFlow and so on. That can be a big mistake if you don't, if you don't have the appropriate data, you don't have the appropriate training set sizes and so on to do that, because, too small data into, a nonlinear mathematical model is going to give you very bad results.
Yeah. Yeah. Okay, cool.
Other questions?
Well, I had one other question. I didn't post it. So, I took like 3 stats classes in my life. Do you guys, do others, kind of provide like data services jockeys on demand? Is that available out there? Because this is very complicated stuff. In my view, SQL's pretty easy for me. I got that figured out. I know how to do that. But you start getting into these kind of models and this prediction and things, and I would go back again and say smaller companies, sort of $500 million, $1 billion companies that are not really focused on the consumer as much and don't have a bunch of marketing people in them. Yet we still may have some problems that we could solve and do interesting things for. How do we get into this kind of capability?
So very often, you'd want to engage a third party. So we, Teradata, have consultants that focus on advanced analytics capabilities, but there are lots of boutique consultants around that also will do that. And part of the goal of the Teradata Vantage software is to make it so you don't have to be a rocket scientist to use it. So if you are SQL competent, and it sounds like you are, then you should be able to use all of the functions that I just described. Now that does require you to have some statistical background. So it can be very dangerous to do a bunch of, prediction without understanding the basics of statistics, causation versus correlation, how to do back testing and so on. But from a technology point of view, the Vantage software will make it pretty easy for you to do that. But I don't want to discount the investment that you need to make in what I'll call data literacy to sort of understand how to build predictive models that have meaning.
Yeah, I was going to second what Stephen was saying. Is like some of those linear models, like a regression model. In theory, I got a D in stats too, but I know what a regression model is. But yeah, you can probably consult with a boutique kind of consultant that could provide you more machine learning quals. But I'd even say some of your data analysts could go get a Coursera learning on just, basic statistics and what, having a certain amount of numeracy. So some of it you can do yourself with a little bit of learning, and then some of it you might want to work with a boutique firm. Like Josh, are you going to say something?
We're going to say it for you, but go ahead.
No, I was going to say like Trace3, I'm sure they have data scientists and analysts on staff.
I like it.
Mike will connect you with all of them, okay?
We've also had success for those of you who are in San Diego. UCSD has a very good data science program. So you can also kind of, you know, we get a lot of well, not during COVID times, but normally we get a lot of interns from UCSD and so on. And you can get them projects. They're very enthusiastic. You need to give them some guardrails on how to solve the problem. But there's, you know, you can be creative, especially if you're a small business. There are a lot of hungry, you know, undergrads and grads out there that are, you know, the hardest part for them is to get real problems to work on and real data. And so it's a good, you can get those skills and they can get a, you know, real experience with real data. It's something I would definitely encourage you to do. So we're a big supporter of UCSD in the San Diego community.
Cool. Stephen, thank you very much for your insights. That was really been helpful. Like to thank you for your sponsorship as well. So Steve Philpott, I'd like to turn it back to you. We're coming to an end. So I'm going to share the final image here and turn it over to you, Steve.
Yeah, no, great, great, Naresh. Thank you. I definitely want to thank all the sponsors, Trace3, Snowflake, and Teradata. Very much appreciate your support and very much appreciate the information provided. You know, hopefully it stimulated a lot of questions and thoughts for follow-up and discussions. What we've got on the presentation right now are some of our upcoming events. So looking through the rest of the year, on August 18th, we have a virtual panel webinar. We're still working on the topic for that one, but it'll probably be related to some of the discussions we had in some of the breakouts about, you know, the return to site. You know, at our company, we don't call it return to work because, you know, we're already working remotely, but that return to site, you know, what are people doing? What are some of the precautions, et cetera? It'll probably be focused something in that particular area. September 29th, we've got the leadership event, and it'll be featuring the CEO of WD-40, a local San Diego company. So we're looking forward to that one. On October 27th, this is normally our annual all-day CIO summit that we do in partnership with HMG. We're still working through exactly what that format is, but October 27th will be the date for that particular event. And then December 3rd is our member holiday social. Again, normally it's a time for us to get together someplace. Not sure what status we're going to be in, but we're gonna hold the date for that one. So those are our upcoming events. I do want to make kind of a request out to everybody is that there's a lot of dynamics going on. We're trying to redo events, reformat things. If you have feedback, if you have thoughts, if you have ideas on topics, please go ahead and send them in to somebody in the SIM board or myself, etc. Again, we're trying to adjust these as much as possible in order to kind of meet the needs of the questions that people have, the issues that people are going through, etc. You know, thank Frank from the winery. Now, I wasn't actually able to finish all 2 bottles of wine, so I don't know if I'm behind everybody else or not. But the wines were very very delicious, so appreciate that. So we're going to end on thanking everybody. Stay safe, socially distanced, and we'll look forward to seeing everybody at the next event. Thank you.
Thank you, everybody.
Thanks, guys.
Take care. Have a good evening, and cheers.
Thank you. Thank you, Sim.
Thanks, Rich.
Thank you all.